The order Sclerotinia is a hexacoral, and it is distinguished solely by having a calcareous skeleton. Over the years, especially recently, people have questioned whether the order Sclerotinia is actually a monophyletic group. Monophyly meaning a group composed of an ancestor and all of its descendants. And different studies have given different answers to this question. I show this particular study because it suggests that the Sclerotinia indeed are a monophyletic group. This analysis, this tree here, is a result of analyzing several different types of molecular data and also morphology, 16S, 18S, 28S, and morphology. And here you can see the 6 hexacoral orders. The order Sclerotinia is down at the bottom, and it forms a monophyletic group. Here is the Corallimorpharia, Antipatheria, and so on. But each of the 6 orders of the anthozoan hexacorals appear to be monophyletic in this analysis. And it says here they're all monophyletic, Corallimorpharia being most closely related to the Sclerotinia. Okay. This is the traditional tree of the order Sclerotinia. So I've told you a little bit about the phylum, the class, the order, and now I'm moving down to subdivisions within the order Sclerotinia. And this is the traditional phylogenetic tree. It was constructed a long, long time ago by Vaughan and Wells in 1943 and Wells in 1956. And it was actually based on lots of 19th century works and a synthesis also of early 19th century works and early 20th century works is what it's based on. And today, people that are engaged in marine conservation still use this classification when they're determining the status of different types of corals. So in this tree, you can see that there are 5 columns. There's one here, there's one there, 3, 4, 5. These are the 5 suborders. And there are 33 families. These are all these slanted names. There have been some modifications since this original classification was created, but they're just minor. Varon, for example, recognized 7 suborders instead of 5. But as I say, they're just minor. This is the main framework. And it's based on skeletal morphology. These are the traditional features that play prominently in Sclerotinian classification. First are the corallites within colonies. These are the individuals within a colony and how well they're integrated. Second are the septa. These are the radially arranged vertical partitions within a corallite. These are these structures here. Costae are extensions of septa beyond the wall. The columella is a central axial structure that runs down the corallite. The wall is a vertical structure enclosing a corallite. And the synostium or paratheca is a skeleton between corallites. With regard to suborders of Sclerotinia, these are based on traditional models of septal growth. So these are the radiating partitions within a corallite that I showed in the last slide. And you can see that these are built by discrete rods that are termed trabeculae. And essentially on the upper septal margins, there are teeth, which are shown here. This is dentation. The teeth may be formed by a single trabecula or a trabecula fan. So these sorts of things, the arrangements of these rods, how they're related to teeth on the upper surface, are how suborders were originally distinguished. And here is a molecular analysis, one of the original ones examining these different suborders, and it's based on 16S RNA. Here there are representatives of 7 suborders. These are the Varon suborders. And what you can see from this is that the suborder Archaeocyana occurs both in the upper clade and in the lower clade. The suborder Fungina occurs both in the upper and the lower main clade. And the suborder Favina is all over the place. So in other words, they're not monophyletic groups. And I can continue on down. Instead of this 7-fold suborders, and what we're seeing today is a distinction between robust and complex corals. And so these are two major lineages that were never recognized before until molecular analyses found them. Okay, so I've told you a little bit about the fact that the suborders are not monophyletic. Now I want to move down the Linnaean hierarchy and tell you a little bit about families and genera. This is a tree that was produced by my colleague Hiro Fukami, and in it we were looking at the families within the traditional suborder Favina. There are 7 families in this, and the Favidae are in black. I know you can't read these things, but the colors are what you're supposed to be looking at. Favidae are in black, they're all over the place. Mucidae are in blue, they're all over the place. The Mariolinidae are here and there. The Pectinidae are there and there. Trichophilidae are embedded within this larger clade. There's a Meandrinidae, which is the one monophyletic group shown on this particular diagram. And then there's the Oculinidae. So not only are the suborders in trouble, but also the families are in trouble. And if we look at genera, this is the genus Favia. It is scattered across the tree, and my favorite genus, the genus Montastria, is also scattered across the tree. So there are problems at all of the higher levels with regard to traditional classification. Instead, what we see in this tree is that there are 3 major clades. There is a clade that is restricted to the Atlantic, and this clade was never ever discovered before. And then there are 2 clades that are in the Pacific. One of them contains only Pacific corals, and this one, the second one, contains a mix of Pacific corals and extinct Atlantic corals. So essentially find a completely different structure than traditional classification led us to believe. So this has encouraged myself and Jarek Stolarski to go back and conduct a survey of characters, or morphologic characters, that can be used in classification that would be useful in classifying fossils and tracing evolutionary patterns through geologic time. And we've used 3 approaches to survey characters. We've been looking at macromorphology, which is the traditional approach using 3D observations with a regular light microscope. We've been using micromorphology, 3D observations made using scanning electron microscopy, and also microstructure, which involves transverse thin sections. These are microscopic thin sections. And also scanning electron microscopy of polished and etched transverse sections. And to better understand patterns of character evolution, we've been mapping character states onto the molecular tree. So the actual topology of this tree is that molecular tree that I showed you earlier, and here are the 3 main clades, the Pacific 2, the Pacific 1, and the Atlantic clade. And superimposed on this, all these colors, are the character known as number of septal cycles. And what you can see is that the purple or the magenta, whatever color this is, these tend to be more basal or primitive. And from this character state, you see less than 3 septal cycles and 4 or more septal cycles arising, but they arise many, many times, suggesting convergent evolution. In other words, the same feature is evolving in different groups. Also in this, you can see measures of how well this characteristic maps onto the molecular tree, and these include consistency indices and retention indices, which range in values from 0 to 1, and all of these values are relatively low. A couple of them have potential, but in general they're relatively low. Okay, another traditional type of character, macromorphologic character, involves corallite budding. Here again we've mapped the states of this character onto the molecular tree. You can have multidirectional budding, bidirectional budding, circumoral budding. And in general, you can see that each one of these states has arisen several different times. The magenta state and the black state has also arisen several times. And not only, or essentially, these statistics down here are better than before. But what you can see from this is that they're not providing any, this character is not providing any information about the relationships towards the base of the tree, and that's what we're really interested in doing, is finding characters that help us with the relationships towards the base of the tree, and so this character is not really very helpful in that respect.